Hey, Dave Staldlin here. Let's do some good math. Let's talk about prime numbers, composite numbers, factorizations, and common factors. So the first thing is we need to determine what is a prime number versus what is a composite number. Okay, so let's talk about a prime number. I'll tell you right now, 13 is a prime number, and here is why. Because there are only two numbers that evenly divide into 13. They are the number 1 and the number 13. 2 doesn't divide in, 3 doesn't divide in, 4 doesn't divide in, and so forth. Those are the only two numbers. A prime number is a number where only the number 1 and the number itself divide into it. So for example, what are some prime numbers? Well, 1, 2, 3, 4 is not, because 2 times 2. 5. 6 is not, because 2 times 3. 7. 8 is not, because 2 times 4. So at this point, any even number is not prime. So 7, 8, 9, 3 times 3. 10, 2 times 5. 11 is prime. 12 is not. 13. 14, 15, 16, 17 is prime. 18 is not. 19, 20, 21, 22, 23. So you can continue going. These are all prime numbers. Okay? Now, what is a composite number? A composite number is a number that more than just the number 1 and the number itself divide into it. There are other numbers that divide in, like in this case, 3 and 5. Okay? Now, let's do another one. Let's do something like the number 16. Well, what divides in? 1 and 16, 2 and 8, 4 and 4. Okay? So some of these numbers are prime, and some of them are not. So what happens is we get into what's called a prime factorization. And let's do it for the number 16. So let's start and let's find a number not the number 1 that divides in. So like the number 2 divides in, and we're left with 8. 2 is prime, 8 is not. Now, what divides into 8? 2 does, and 4. 2 is prime, 4 is not. 2 times 2. Now we have 4 prime numbers. So, oops, you couldn't see that the whole time. Oops. So 16, 2 and 8. 8 is not prime. 2 times 4. 4 is not prime. 2 times 2. So now we know 2 times 2 times 2 times 2. That's the prime factorization of 16, 2 to the 4th power. Let's do one more. Let's do something like 24. Okay, so let's see. 2 divides in. That's prime, and then we're left with 12. Let's see. 2 divides in, and we're left with 6. 2 divides in, and 3. Those are all the prime numbers. So 2 times 2 times 2 times 3 is the prime factorization of 24, and this is the same as 2 to the 3rd times 3. Okay, now that we've done that, let's talk about greatest common factor between two numbers. Let's say that we have the number 40 and the number 60. And we want to find the greatest common factor between those. Well, here's what we're going to do. We are going to find the prime factorization for each one of these. So, for example, this is 2 and 20. This is 2 and 10. This is 2 and 5. And so we have 2 to the 3rd times 5. Or you could think about it as 2 times 2 times 2 times 5. Okay, let's do the same for 60. Well, we have 2 and 30. We have 2 and 15. We have 3 and 5. Those are all primes. So this is the same as 2 times 2 times 3 times 5, or 2 squared times 3 times 5. Okay? Now, what do we do next? Well, what we want to do is we want to match up the powers that match. So let's do it like this. This is 2 times 2 times 2 times 5, and this one is 2 times 2 times 3 times 5. So we're going to take those match, those match, those don't, those match. So essentially we have 2 times 2 times 5, which is 4 times 5, which is 20. 20 is the greatest common factor. Now, what does that mean? This means that 20 is the largest number that will divide into both 40 and 60. Okay? The largest number that will divide into both 40 and 60. All right, let's do one more, but let's do it with some variables. Okay? So let's say that we have 6 a to the third b, and we have 4 a squared b. So we want to find the greatest number that divides into 6 and 4, and we want to find the greatest variable that divides into both of those. So let's do this. Essentially, this is 2 times 3 times a times a times a times b. And this is, I'm going to do this one down here. 4 is 2 times 2, and then we have a times a, and we have b. Now, what matches up? 2, a, and b. And so we have 2, we've got a squared, and we've got b. That is the greatest common factor. That's the largest number and the most a's and b's that divide into both of those terms. All right, that's a little interesting. So let's do on page 189. Let's do 1 through 4. Let's do 9 through 16. Actually, let's not do 9 through 16. Let's do 17 through 24. And I think that's good. Try those problems on for size. Okay, that's it.